Welcome to Study Loop.
In this problem, you have two convex lenses a distance of 30 centimeters apart. One has a focal length of 20 centimeters, the other has a focal length of 4 centimeters, and you have a candle that's being placed 100 centimeters from the first lens. So you have I'm going to call this DO1 of 100 centimeters. And we want to calculate where the image is located and what information we can tell from that image. So to first figure out the distance of the image for the first lens, we're going to use 1 over DO plus 1 over DI equals 1 over F. We get 1 over DI by itself, and then we get just DI by itself by inverting the entire fraction. This gets us a distance of the image of 25 centimeters. So that means there's 25 centimeters on this side that our image is being created, which means, so I'm going to call this DI1, the distance of the image for the first lens. And that actually tells us, so 30 minus 25 gives us a distance of the object for the second lens, which is, again, 5 centimeters here. So using the same equation, this becomes DI2, 1 over F minus 1 over DL. Using the same equation, we can calculate what our new distance of the image is. So that gives us 1 over 4 minus 1 over DO, which is 5, gets us a distance of the image of 20 centimeters from the second lens. So our image is over here if our object was over here. Now we want to determine the magnification of this. Because both of these are positive values, we don't have to do anything different here. So this becomes DI1, which was 25, times DI2, which was 20, all over DO1, which is 100, times DO2, which we said earlier was 5. This gets us a magnification of 1. Since this value is positive, this image is upright, which makes sense because the first time it would have flipped the image inversely, and then the second lens flips it one more time. So this is an upright image, and because the second value is positive, because we have DI2 to be a positive value, we do have a real image, which means this can be projected onto a screen.